Hey class, we're on part 2 of prime factorization. I'm going to go ahead and erase the board from last time. So we finished up our first example of prime factorization, and now we're going to go ahead and go to our second example. Okay. Example 2, prime factorize 80. Okay, prime factorize 80. And so we want to actually prime factor 80, and we also want to get it in standard form, right? Standard form is the standard way that we write numbers. We want to get it in expanded form, right? That's the all the way expanded out, all the factors, prime factors. And we also want to get it in exponent form, right, in exponents. So let's go ahead. We're going to go ahead and use our factor tree. I'm going to write that down here. Use factor tree. Okay, so we're going to use a factor tree. Okay, use factor tree. So remember, is 80 an even number? Yeah, it's an even number, right? Even number, and so that means we can actually start off with 2. Remember, we're trying to find two numbers that multiply, right? That's factors. Two numbers that multiply to get 80. Of course, you don't have to start with 2, but I like 2 because, again, it's an even number and it's just easier to work with. So you can even do 80 divided by 2 or half of 80. You can think about it that way. And, of course, it's 40. And what helps me here is that the number 2 is a prime number. So we don't have to worry about going this way with it. Okay, and you'll see what I mean later. So is 40 an even number? Yeah. So we can actually use 2 again. 2 times what? 2 times 20, right? And then again, 2 times 10. And then finally, 2 times 5. Okay? And so we end up with a 2 here and a 5, right? So again, 80, I like to write it right here next to it, is 2 times 2. Remember, we're using the dots for the multiplication. It's a lot easier, right? We're using the dots for multiplication. Times 2 times 2 times 5. Okay? 2 times 2 times 2 times 2 times 5. Okay? And so let's think about what's 2 times 2? 4. 4 times 2? 8. 8 times 2? 16. And 16 times 5 is 80. Okay? Again, if you don't know your 16 times tables, like some of us, I mean, I don't either, right? I got to write down some work too, right, sometimes. 5 times 6 is 0. I'm sorry, 5 times 6 is 30. Bring my 0 down. Carry my 3. 1 times 5 is 5 plus 3 is 80. So 16 times 5 is 80, right? And so that's how we know that this is correct. That's how you check it, right? And so now, again, this right here is standard form. I'm going to write that over here. Standard form, 80. This one is expanded because it's expanded, right? And then now we need exponent form. So we see how many 2's do we have being multiplied, right? We know repeated multiplication is exponents, right? Or exponents. So we want to go ahead and write that 2 as our base. And what's going to be our exponent? Remember, the exponent tells us how many there are. How many are there? 4, right? So our exponent or power is going to be 4. And is there a lot of 5s? No, there's only 1, right? So we just times 5. We're going to go ahead and box that. This is exponent form. Okay? Exponent form. All right? Now, before we move on, I want to go ahead and prime factor 80 without using 2 as my first factor. So I'm going to scoot this over a little bit so you can see it. I'm going to do it over here. So let's say we have 80, but we don't want to use 2 as our first factor. We want to use other factors, right? Not 2. So let's think of two numbers. Let's do 8 and 10, right? 8 and 10. Now, 8 is not prime. See, 2 is prime, so we don't have to go this way, right? But 8 is not. We have to actually think of another number. We're not going to circle it because we only circle with prime numbers. And so in this case, we know that 2 times 4 is 8. And 2 is prime, so we can circle 2. Is 4 prime? No, right? So we have to actually prime factor 4 as well. And we're going to get these 2's here. So we're going to circle those. Okay? Now let's go back to 10. 10 is the same thing as 2 times 5. Is 2 prime? Yes. Is 5 prime? Yes. 4 was the one that wasn't, so we didn't have that. So we now end up with 2 times 2 times 2 times 2 times 5, which is what we had up there. This is what we had in our expanded form. So this is the same way of doing things, right? This is the same thing, but I like to, again, this is why I like to use the 2, because it's easier to work with, okay? All right, let's go ahead and move on. We'll go ahead and example 3. Example 3. Prime factor 300. Prime factor the number 300. It's a bigger number, okay? So here we go, 300. We're still going to use our factor tree, right? We're going to use our factor tree. But again, like I said, I like to start off with the number 2. Okay, it's just easier to work with. So this 300 is even. Since 300 is even, meaning we can cut it in half evenly. Why not? Half of 300 is 150. Right? Half of 300 is 150. 150 is still prime. So half of 150, again, we can circle these numbers because they're prime. Half of 150 is 75. No, circle that. It's not prime. 75. Now, is 75 even? No. We have to think of two numbers. And I like to think of my number here to be prime, right? And the other one might be or might not be, right? So for 75, we think of quarters. At least I do. You should too. And so we know that 3 times what? 25 is equal to 75 because we can think of quarters, right? And then 3 is prime, so we'll circle it. Is 25 prime? Can we break it down anymore? 25 is not prime. We can still break it down, right? It's composite. So we're going to go ahead and break it down into what times what? 5 times 5. 5 is prime, so we circle it. Okay, 5 is prime, so we circle it. So now we have our prime factorization. 2 times 2 times 3 times 5 times 5. So again, we have our standard form. We had that from the beginning. Right? We have our standard form. We have our expanded form. Right? We have our expanded form. Now we need our exponent form. We need our exponent form. So, how many 2's do we have? We have 2 2's, right? So we know our base is going to be 2. Our exponent is also going to be 2 because we know that there are 2 2's. How many 3's are there? Well, there's just one 3, right? So we're going to multiply by 3. You can say to the first power, but really there's no reason to do that. Okay, there's no reason to say to the first power. Okay, to the first power, there's no reason to do that. And then how many 5's are there? Well, there's 2 5's. So we have 5 to the second power. Okay, so this is exponent form. Okay? All right, so again, this is our third example for prime factorization. Thanks for watching, guys.